Y'all, you're so annoying.
Professor.
Yep. What's up?
I had a couple questions.
Sure.
So in the weak form of the 1D elasticity equation,
Yep.
I was confused as to what would you plug in for A of 0 and W of 0. I know that it depends, right, in the equation, depending on like where the traction boundary condition is on the domain. If it's on the uh, where x equals 0, x equals out. But I
Yep.
was just confused as to like what would W of 0 be and A of 0 be
Yeah.
for
Yeah.
those situations.
Yeah. So actually just had it open. I was
Oh,
writing your
okay.
guys' again earlier.
Mhm.
And so you're talking about like this term right here, right?
Yeah, exactly.
And so for this, for the traction boundary condition, this is basically what these represent is we're evaluating both the weighting function and the area function at the same location as the traction boundary. And so in this derivation here, I basically did the case where our traction boundary condition was at x is equal to 0, and so that's why I
Mhm.
evaluated these at x is equal to 0, x is equal to 0. But if the traction boundary condition was at the other side, then we would evaluate these at x is equal to L, x is equal to L for the A.
Right.
And so let's do just a quick example. Like for right here. So here, if we look at the situation right here, we have basically a natural boundary condition on the right, a Neumann boundary condition. Here it's no
Mhm.
heat flux, and so in the end it's just going to cancel out. But if you wanted to evaluate this term in the weak form, it would be this term right here, right? This is basically
Okay.
the same. This is basically the same thing. And so we're going to evaluate W. We're basically because we have a function W of x, right? And
Hmm.
so W of x, we're just going to plug in x is equal to L. And then for the A, you're going to plug in x is equal to L for A as well. Um, and so the area, a lot of times the area is not going to change with x. And so the area might just be a constant. And so if your area is just a constant right here, you would just plug in this case, it would be 0.5. You would just plug in
Hmm.
0.5 in for A right here. But for cases where the A does change, we find a case that does. Might be in the homework actually. Let me see.
Yeah, like the homework, the optional problem. I think it was or one of those. Yeah, the
Right,
area changes.
right. E.
I think it was the one. If you scroll down, the one with the weird, like the trapezoid shape. That one.
Yes. Yeah. So here the right here. So area is equal to 0.5 minus 0.1x, and so you would just plug in x is equal to L, and then that's how you would evaluate the Neumann boundary term.
Okay. Oh yeah. So one more thing. So okay. So for the weighting function, when you plug in, so for example, whatever the value is, like L, right?
Yep.
W of L.
Mm-hmm.
What would it be equal to? That's the other thing I was kind of confused. That's what would that equal?
It wouldn't equal anything. It would just equal to this. And so when you're plugging in, you would plug in this functional expression right here, but with x is equal to L, and you just plug that straight in there. Yeah.
Oh, I see.
Yeah.
Oh,
So
okay.
you would have a B term probably still left over, probably likely B1, and then that's just going to be part of your answer because when you do the weak form, you're going to end up setting up a system of equations for two equations for two unknowns usually, or
Hmm.
maybe one equation one unknown, and then this would just be part of it.
Okay. Okay. Yeah, because I was trying to do 3C, and then I got stuck at that part, and
Yeah.
then I just left it because I was just like, I'll just wait for the solutions, but I gave it my best shot
Okay.
for
Yeah,
that.
that's all I can ask for is your best shot. So,
Yeah.
and so yeah, I'll post the solutions probably sometime. I need to grade them first, so maybe sometime tomorrow I'll post the solutions.
Okay, for sure.
Yeah.
Um.
Professor,
Yeah.
oh,
What's up?
just a question on the homework. So I know that the condition for the weighting function I saw in the notes was that it's zero at the with the I forgot the name of the boundary condition, but
Yeah. The Dirichlet boundary. Yeah.
the
Mhm.
duration. So it's zero there. So then for our problem, I think it was problem 3 where both sides were had the temperature displayed. That was our boundary condition.
Yep.
Would then the weighting function be zero at both sides?
Yes. Yeah. So you would apply it twice, and so you'd have it be zero here, and you would have it be 0 here as well. And
Yeah, so I did that on the homework, and maybe I'm doing something else wrong. But when I did that, I got my what do you call it, system of equations to all be equal to 0, and then I got my answers to all be equal to 0. I don't know where I went wrong.
And so you should, and so so you're talking about this one, right?
Yes.
Right, and so you need to apply the same thing for t as well. And so for t, you need to set t of 0 equal to not 0, but you're going to set t of 0 is equal to 100, and you said t of L is equal to 25. And so that's going to allow you to solve for 2 of these constants. Where'd you go? It's going to allow you to solve for A0. A0 for sure that you'll be able to get, but A1 and A2, you're not going to be able to solve for them outright, but you'll be able to solve for one in terms of the other one. And then in the end, by the time you end up plugging it into the weak form, your T of X and W of X are only going to have one more unknown that you don't know yet.
I see.
Yeah. Yeah, it's a different one, and so I gave you that one on purpose on the homework just to kind of make you guys think a little bit. But yeah, in the end, by the time you plug into the weak form, you should only have one constant remaining in T of X and W of X.
Yeah. I see. So then, I also had a quick question on the Ansys activity. We or I was doing the one that's due tomorrow, and I saw that for I think it was part 3. You wanted us to show the distribution, but it's like over time it's different. So do you want us to have a bunch of screenshots that show each, like, I don't know, every couple second interval, or like how do you want that?
Just the ending one, and so whichever one's
the
at
last
the end.
one.
Just the last one is fine. Yeah.
Okay.
Yeah.
Because I had like a whole bunch of screenshots in there by the end.
Yeah, just one of them is fine. So just whichever one you find at the end. And so if it's something like this initial image right here, it could be at any time after the car, basically any time after the car contacts the wall, and so anything like that is fine. Yeah.
Oh, anything. Oh, okay. Okay.
Yeah. And so these activities are for mostly for you guys to kind of learn Ansys. And so I'm not checking anything for like strictly correctness for these, because it's mostly for you guys, because it's an elective class, right? It's not anything that's that I need to assess you guys hardcore on. And I figure you guys would want to learn Ansys because first of all you're in this class, and then you also need it for the final projects. And so yeah, just show me screenshots just to show me that you did it, and then that's good for me.
Okay, sounds good. Thank you.
Yeah. Okay. All right, so let's go ahead and get started today. It's 4 o'clock. All right, so how's everyone doing today?
Alive.
It's good. It's always a good thing. Better alive than not. Hanging in there. I know it's a tough time. That's for sure.
I'm still alive, but I'm barely breathing.
As long as you're breathing, that's good. Okay. And so actually, Ronald, you did remind me. So I forgot to post the poll. And so I'll do that after probably after 7 o'clock today, because I do have another lecture after this. But I'm going to post a poll today where you can vote on the topics that you would want to see in the midterm review. Okay, because our midterm is going to be next Thursday, and so a week from today. And so I want to make sure I get the review video to you guys by this weekend, so you'll have that available for you for study. Okay, and so I'll post the review. I'll post the poll, and you can vote on just whichever topics you want to see the most. And I'll record the video sometime tomorrow afternoon. Okay. All right, and so today we have a new Ansys activity planned, right? And so this is Ansys activity 5, and the title of this activity is "A Bridge to New Element Possibilities." Right? And so we kind of just finished talking about a lot of different element types, things like triangles, quadrilaterals, tetrahedrons, hexahedrons. But that's only just barely kind of scratching the surface of what's available for just finite elements in general. And so today we're going to go over two new element types. One which may be familiar, which might dredge up some bad memories. And so these are called the shell and beam elements. Okay? And so these are kind of very special element types that you can have in your Ansys analysis, but they serve a very, very important purpose. Okay, so that's the only plan I have for today, is just to kind of run through this activity. It is a little bit a little bit more technical than the previous ones, where like there's kind of a lot that you have to do. And so, if you want to follow along, as always, that's always great. I would boot up Ansys right now because we're going to do quite a bit in Ansys today. Okay, not really in Ansys, but mostly in SpaceClaim, which is the CAD software that comes with Ansys. Okay, and so besides that, homework, the homework 3 was due last night, and then we have Ansys Cad V4 due tomorrow at midnight. Okay, and so make sure you guys are working on that. And if you're running into any issues, as always, you can always just let me know, and I'll do my best to help you out. All right. So any questions on anything before we get started for today? Okay. All right. And so let's go ahead and get started with Ansys Activity 5. Right. So this is the title for this activity is a bridge to new element possibilities. Okay. And so up to this point, we've gone over the 3 element types, which are tetrahedrons and hexahedrons, right? And so I feel like we're all pretty familiar with these because we've been using them this whole time, and and we kind of learned a lot of the specifics on them over the last couple of weeks. Okay, and so both of these element types, even though there are different shapes, they're often categorized in kind of the same element type. So these are often called solid type elements, and because they're literally 3-dimensional solid objects, right? And so these work great in situations when your geometry, and here I say it's like a cube, but basically when your geometry has about equal dimensions in every direction, right? And so it's equally thick in X direction, equally thick in Y direction, and equally thick in Z, approximately. It doesn't have to be exact, but basically, you want a situation where you can kind of fill this 3-dimensional space with elements, and you get kind of a good element density in every single direction. And so what I mean by element density is that, you should have several elements across the thickness, right? And so if you look in any direction, you should go across several different elements, right? And so that's what I have here. And so if you go from kind of the top of this square to the bottom, you cross over several different layers of elements. And this is generally what you want, because this is what's going to give you, a good quality solution, right? And if you look this way, from left to right, you see the same thing. You see several layers of elements. So this is always a good sign, and if I'm honest, this is when I'm assessing other people's finite element simulations. This is kind of what I look for, and so I look to see if there's several elements through the thickness here, especially if they're reporting on results like stress and things like that. Okay, because stress is really sensitive to element density. But a lot of times, the geometries that you end up working with in practice they don't really look like this, right? And so in particular, we tend to work with a lot of geometries that are thin and a lot of geometries that are slender, right? And so what that means is basically one of the length dimensions for that geometry is significantly less than the other ones. Okay? And so I have one example here where like this geometry here is a kind of a thin rectangle, and it's fairly long in the left and right direction because we can see up several different different layers of elements as you go from left to right. But as we go from top to bottom, you can see that we only have one layer of elements here. So that's a little bit of a warning sign to me that maybe the simulation results here aren't the best, especially if you're doing things like stresses. Okay? And the reason why these types of geometries struggle is because when you're doing like a structural type of simulation, the main thing that Ansys is computing is just the displacements, right? And so we see that, we've seen that in our hand problems too, that we solve for U, which is displacements. Okay. And so if you try to compute stresses just from the displacements, and you have a situation with you only have one element through the thickness, one layer of elements, then that's kind of a warning sign that maybe your simulation results aren't that accurate, because you can see you have one node right here which is already on the exterior of the surface, and another node here which is on the exterior of the bottom surface. Okay, and so that's not good because you want to have some nodes in the middle here to kind of help you compute those things. And so what do you do in these situations? And so if you run into situations like this, one option you can have is you can just refine your mesh like crazy. So you can add a crazy amount of refinement and make a bunch of really tiny elements in here, such that you go through the thickness with several different layers of elements, right? And so that's one option, and that's fine. That'll give you good results. The only problem with that is that, the cost can start to add up really quickly if you start to do that. Okay. But there's a more effective option for that, right? And it kind of goes back to what we were talking about kind of at the very beginning of class, where we had these beams, right? And so if you remember our beams were these one-dimensional elements, right? So they were only just constructed with the line. But in addition to the displacements, if you remember, back when we did beam problems, we also solved for the rotations at each of the nodes too, right? And that's key, because from those rotations, that gives you kind of an additional degree of freedom that you solve for at these nodes to make your solution a lot more accurate. Okay. And so we can actually utilize this in Ansys as well. And so in Ansys, if you have a geometry which is, has a lot of parts that are really thin or very slender, what you can do is that instead of trying to mesh these guys with either tetrahedrons or hexahedrons, we can break them down into literal 2D objects or 1D objects, and then model them with specialized either shell elements for 2D or beam elements for 1D. And then that's going to be a lot more efficient in terms of your results. And you're going to get accurate results with much less mesh density than you did before. Okay. And so for this activity, we're going to learn about, what beam and shell elements are, and how do we call upon them? How do we summon them within Ansys to help us do our analysis? Okay. And so for this analysis, I have this CAD of a bridge where you can see here that most of the structural parts of this bridge are either very, very thin or very, very slender. Okay. And so if you try to do a finite element analysis on this with tetrahedrons and hexes, you're going to have kind of a bad time, because in order to get an accurate result, you have to really refine like crazy, and that's usually not really a practical thing to do. Okay. And so for this activity, we're going to take this CAD, we're going to convert it into a system of beams and shells, and then we'll run that into Ansys, and then we'll see how the simulation results look like. Okay. And I chose this CAD on purpose. Well, okay, that's not true. So I found this CAD on GrabCAD, and it ended up having a lot of imperfections to it that you'll see, which was actually good. And it's because from this activity, you'll be able to see how do you deal with the CAD that may not be really perfect for your purposes, and how do you kind of clean that up in order to kind of perform a finite element analysis on it. Okay. Okay. So any questions on this before we open up Ansys? Okay, so let's go ahead and open up Ansys, and let's go ahead and get started. Okay? And so if you open up Ansys, you'll come up to Workbench just like this. Okay, and just like we've done in the past, before Ansys Activity 4, we're going to run a static structural simulation. So you're going to drag and drop static structural from the left and into the middle here. Okay, and then let's go ahead and import our geometry, like we've done before. So we're going to right-click Geometry. You're going to click Import Geometry. I was testing this earlier, and so I already had it loaded. But for you, you can go ahead and load the file, right? And so if you go to the Canvas site and you can download the CAD file, it should be called bridges.iges. Okay. And so you can load that geometry, and it'll show up here. And we can go ahead now and open this up in SpaceClaim. Okay. So you're going to right-click Geometry here, right? After you've imported the bridge geometry. And then you're going to click Edit Geometry in SpaceClaim. It's going to take a little bit of time to open up SpaceClaim, because it is a fairly heavy software.
Hey, Professor.
Yep. What's up?
My computer's telling me I don't have anything to open this file.
Oh, so it's so you double click it and then you can't open it at all. Were you able to load the previous activities, like the step files and all that stuff?
Yeah, this one's giving me trouble though.
Okay, let me see if I have a different form for the for that CAD file. Let me see. Let's see. I might only have the IGES file. Is anyone else running into that same issue?
I didn't have this issue, but I know there was a setting somewhere at the beginning where you can choose what kind of files Ansys can import. And I think there's just a checkbox you need, and that should fix it.
Let me try uploading the just the IGS file. Let me see if that works. I think this is a. Oh, these are actually the Ansys Cad files. Let me upload this and then let's see if that works. Actually, let me try opening this first. Let me see if that works.
Not sure. It worked for me. I just right-clicked geometry and then imported geometry, and I clicked on the bridge. Is that kind of what you did, Christopher?
No, it's not. It's not allowing me to download it onto my computer at all.
Oh, you can't even download it?
No,
What browser are you using?
Chrome.
Did you click on the link or the like little arrow download button?
So when you go to the try downloading it from the files folder, and so when you go to our site, click on files, and you click on Ansys files right here, and then see if you can download it straight from here.
Yeah, it's telling me there's no preview available for this file.
Okay, I think that's okay. Just go ahead and just download it because it's I don't think Canvas will be able to preview it because it's a CAD file. Oh yeah. So the link might be a little bit old, and so if you can try going to the link that's in the PDF as well, and so you can go to this GrabCAD site and see if that works. Okay, still here, perfect. Yeah, so if you go to the PDF and then you go to this site right here, you can download the CAD file from that as well.
Okay, I'll figure it out.
Okay, yeah, let me know how it goes. Okay, and so you open up the CAD file in SpaceClaim and you should get this, right? And so this is our first time in SpaceClaim. And so SpaceClaim is kind of Ansys's version of SolidWorks. It's interesting because SolidWorks is kind of trying to do its own simulation thing, so it's kind of trying to encroach on Ansys's territory, and Ansys is also trying to create its own CAD software, so it's trying to encroach on SolidWorks territory. So everyone's kind of crossing over each other's territory. Okay, and so our goal with this part is we want to basically take this geometry where everything here is a 3D object and then replace them with either 2D or 1D objects. Okay, and so you can see here that this black part on the bottom here, this is the road, and so we're going to replace that with a 2D shell. Okay, all these slender columns right here, we're going to replace those with beams because they're pretty thin. Okay. And then the sides, we're also going to replace that with a shell as well. Okay, and so the first thing you should do, where like if you say that you have a geometry that you want to replace it with shells and beams, is that we need to kind of clean up the surface a little bit, right? And so the first thing we're going to do is we're going to go to Repair up here on the top bar, right? And then from Repair, we're going to click on this button called Stitch. And so what Stitch is going to do is that, if you have kind of a rough looking CAD, or the CAD, might be, have a little bit, some things aren't really connected, this Stitch button right here will kind of clean things up and kind of put things into a single body. Okay. All right. So let's go ahead and click Stitch. Okay. And then after you click Stitch, then you might have a notification come up here on the bottom that said no areas found, right? And that's good. And so that means that our surface is looking good. But if you if you try doing stitching with your own CAD, and then you can click, and if this green check mark here was highlighted where you can click it, then I would suggest that you click that check mark right there just to make sure that everything is good. All right, and so the next thing that you should do is you should click gaps. Okay, and similarly, this is going to check to see if there's any gaps in your model. Okay, and you can see here that there's one area that I found. And so let's go ahead and click the check mark. And so in this case, it will say that no problem areas were fixed because this part of the geometry is kind of a weird thing. And so, we'll deal with this later, but in most cases, when you click gaps and you click, this check mark, then it should kind of fix some things in your geometry. Okay? And so just to recap, first thing we did was we went to repair and we did stitch and we did gaps. And this is mostly just to kind of clean up the surface of your model, just to make sure that it's good for, for the next step, which is, producing shells. Okay, so any questions on this so far?
Sorry, I might have missed it. Did we stitch anything or just gaps?
No. So for this model, there was nothing to stitch and nothing, and no
Okay.
gaps to fill. But I was just showing you where that was. So if you wanted to do this for your final project, you might catch something with stitching. Yeah.
Got it. Thank you.
Yeah. Okay, and so now let's go ahead and create shells. Right? And so the shelling operation is called mid-surface. Right? And so what this does is it basically takes two surfaces that are close to each other in your model, and it eliminates those and it creates another plane that's right in the middle. Okay, and so that's why it's called mid-surface. Right? And so to use this operation, the way we can use it is first we have to click it. Right? And so we're going to go to prepare here at the top and then click on mid-surface here. Right? And then from here, what we have to do is we have to select the two surfaces that we want to mid-surface. And so I'm going to do an example first with with one of the sides. Okay, and so first thing you're going to do is you're going to mouse over kind of this broad side right here and make sure that broad side is highlighted. So go ahead and click once. Okay, and so after you click once, then that surface will be highlighted, and then you're going to click on the surface that's opposite to that, which in this case is the interior one. Okay, and so once you click both of those surfaces, then one of them should turn blue, which is the first one that you clicked, and then the other one should turn green. Okay, and ideally these two surfaces should be very close to each other, and they should be parallel, right? Because what Ansys is going to do is it's going to split right in the middle of them and then create another surface that's kind of right in between. Okay, and so when you're ready to mid-surface, you're going to go ahead and click this green check mark. Okay, and then you can see here that Ansys has created this surface which is right in between. Okay? And so instead of having this kind of bulky 3D surface, what we have is this kind of paper thin shell that replaced it. Okay, and the location of that shell was right in the middle of where those two surfaces were before. Okay, so was everyone able to create a mid surface for this one? Great. All right, so let's go ahead and do that for the other side as well, because we have the other side of the bridge that we need. So make sure that you're going prepare mid-surface. And let's go ahead and select both surfaces on this one. Okay. It doesn't matter which one you click first or second. It's all the same. And so in this case, I click the inside one first and the outside one. Okay. Let's go ahead and hit the check mark. It's going to create our mid-surface, and then we are good to go. Okay, and so there's one more mid-surface that we have to do, and that's for the road. Okay, and so let's go ahead and do that. And so let's go to prepare mid-surface, click on the top surface of the road, click on the bottom surface. Right? You see both surfaces are highlighted here. Click the green check mark. And you can see here we've created a thin surface for the road.
How do you do the road again?
Yep. So the road, you're going to just do the same thing as before. So you're going to click mid-surface, click the top surface of the road, and then click the bottom one, and then click the green check mark here on the side. Yep. All right. And so if you do that, you should have kind of 3 transparent shells here, which are the surfaces that we just created. Okay. So any questions on that?
The road is supposed to turn transparent, right?
Yes. Mm-hmm.
Okay.
Yeah. Make sure when you select both sides of the road, one of them is blue and the other one is green. and then click the green check mark here. All right, so creating shells is relatively pretty simple, and so all you have to do is you just have to have two surfaces that are pretty close to each other. They have to be perfectly parallel, and then from there you just mid-surface them. Okay, and so the next thing we're going to need to do is we need to take each of the columns here and convert them into a one-dimensional beam. And so the way we're going to do that is we're going to use what's called the extract button. Okay? And so you're going to go on prepare up here. Okay. But instead of clicking mid-surface here on the left, we're going to go to the right here and click on this button called extract. Okay. Right. And so if you read the tooltip for extract, what extract does is it extracts a beam from a solid, and the solid must have a constant cross-section, but it can have tapered ends, notches, or cutouts in its line. Okay. And so what the extract is going to do is it allows us to select kind of thin geometries in our model, and it converts them into a beam element, which is a 1D element. Right? And so to show you this in action, let's take this kind of top beam right here. Okay. And you can see when we mouse over it, it highlights yellow. And so we can go ahead and just click that. Just click once. Okay. And you can see that Ansys has converted that that column into just a single straight line, okay? Just like magic. Okay. And so that's basically how you convert things to a beam. And so now let's do the same thing on the bottom as well, right? It's because we have all these different columns right here. And so let's go ahead and click on each of these columns and convert them to beams. Okay. And so you just have to click once. And then once you do that, then all of your model has been converted to shells and beams. Okay. All right, and so I'll say for this example, since we are, since everything here was thin or slender, then we converted everything to beams or shells. But it could be that in your final project or any kind of model that you're doing, that only a portion of your geometry can be replaced with shells or beams. Okay? And so that's okay. And so you can have parts of your model which are still three-dimensional and parts that you've converted to shells and beams. Okay? And so definitely mix and match and try to see what kind of works the best for you. Okay?
So in a way, are we simplifying it, or what's the main purpose for doing this?
Yeah, we are. And so we're simplifying it, because if we didn't do this, then what Ansys would have to do is it would take these, let's take the road for instance, right? And so it would have to take the road and try to mesh that with like hexahedrons or tetrahedrons. And that's really inefficient because, the road is so thin. And so what we're saying now is that, we're taking that three-dimensional object and converting it into a two-dimensional one. And then we're saying, okay, Ansys, like you can use two-dimensional element types for this. And so you can use triangles and quadrilaterals for this. Which is a lot simpler, right? Because if you compare like a triangle and a tetrahedron, like a triangle has a lot less nodes per element, than a tetrahedron, and it'll compute things like stresses and displacements a lot more efficiently than not.
Professor?
Yep. Mm-hmm.
Does it matter that the like beams and the pieces aren't necessarily touching now?
Yeah, so that's the next part. So they do need to be touching. And so the next part is we need to clean up this model to make sure that all the parts that need to be touching are touching each other. Yeah. And so that's one of the main dangers that you run when you convert things, is that you lose that thickness information. And so the main place where you lose that is when we converted these guys, the side supports here. And so you can see no longer this beam is touching that one. And so that's a problem. And so we need to make sure that these guys connect. Okay? And so that's going to be kind of the subject of the next part of the activity. And so thankfully, Ansys actually has an automatic feature to detect things like this and then automatically extend them to make sure that they hit your geometry, right? And so that tool is called this one right here. And so if you go to under prepare, and then you go to this button called extend, okay? And so if you read the tooltip for extend, what this does is it extends surface edges or sketch curves up to the nearest intersecting body. Okay, and so if you click this, right, what it'll do is it'll search for any locations where things can be extended and then it'll highlight those for you. Okay. The problem with this is that it only searches for things within a certain distance, and so that distance is given here in this on this settings here on the left. Right? And so right now the maximum distance that it can travel here is only 10 millimeters. And so instead of 10, because this bridge is a little bit bigger than just 10 millimeters, we're going to change this to 50. Okay. Right. And so after you change the maximum distance for the extension to 50, you can see now that it's found all these different areas, right? And so all the areas here that are highlighted in red, it's saying that, I found these problem areas and I want to extend them. All right, and so to extend the surfaces, all you have to do is that once you find some that are highlighted like this, is just to click the green check mark. Okay. And after you click the green check mark, you can see that things here on the right, they've been extended to match this, to intersect this surface now. Okay. But the ones on the left, it hasn't extended yet. Okay. And so you just have to click the green check mark one more time. Right. And I'll zoom into one of these just so you can kind of see it in action. Okay. Right. And so if you look at these two points right here, they're not intersecting with the left side, which is where they need to intersect. And so when we click the green check mark again, you can see that they've been extended, and then now they hit this wall, and now those ones are good. Okay. Okay. So any questions so far on the extension tool?
Not all of my, I guess, beams were extended.
Yes. That is what should happen, and so that's going to be the next thing, because some of these beams are not aligned with the bridge because we turned them into beams. And this is the part I said earlier where this CAD's not perfect, and so when this guy created his little columns on the bottom, he didn't line them all up correctly, which is fine because now it gives us a chance to see what we can do with these kinds of imperfect CAD models and how do we actually fix them. Yeah, so you should have quite a few. I think maybe like 4 of them that haven't reached full connection yet. And so we're going to fix those. We're going to fix those now. Okay. All right. And so let's go ahead and see what we need to do. And so just to kind of make things a little bit easier, I'm gonna go ahead and hide the road here because it's kind of in the way. And so let's see, the road is mid-surface 3, right? And so to hide a surface, all you have to do is just kind of uncheck it here on the left-hand side, okay? Right, and right now the road is hidden, okay? And so I've only hidden the road just for now, just so that we can kind of see what's going on. Okay. All right, and so what you can do from here is you can, let's view the bridge from the, by looking at the y-axis, okay? And so if you're looking at the bridge kind of just like this, what you can do is you can go to the lower left of the screen right here where the XYZ axis is. And we want to look at things down the barrel of the y-axis. And so we're going to click on the green Y right here. Okay. And then that's going to show us, the top-down view where we can kind of clearly see which beams here haven't been connected to the main one yet. Okay. And so you can see here we have 4 of them. And so we have this one right here up top. And we have the 3 on the bottom. All right. And so now the question is, how come these beams weren't extended to match the surface, right? And so the reason they weren't extended is because right now they're a little bit too low, and they're not actually in line with the bottom surface, right? And so to kind of show you that, let me rotate this and kind of show you what I mean. Okay. And so let me rotate this such that we're aligned with Z. Right. And so you can see now we're looking at kind of the very side of the model, okay? And it's probably a little bit hard for you guys to see on Zoom, but this little dot right here, this is the beam that we were looking at before that didn't connect together with the bridge, right? And so let me go ahead and zoom out. You can kind of see right here, okay? Right. And so I'm looking at this beam right here, which didn't connect. Right? And so if we look at this from the Z-axis, and so let me click on this Z right here. And we zoom in really, really tightly, we can see that this beam right here, is actually underneath the bridge, right? And so it's not actually in line with it, right? And so when Ansys went to try to extend this, it can only extend along the direction of the beam. And so it tried to extend it, but there was nothing for it to intersect to, and so it kind of just left it like that. Right? And so what we need to do here is we need to kind of shift this beam upwards a little bit or to the right, just to make sure that it can intersect with this with the bridge, and then we can properly extend it from there. Okay, and so to do that, we first need to measure how far off we are from this bottom surface. Okay? And so to do that, we're going to use the measurement tool. Okay, so let me zoom in a little bit more just so you can see. Okay? And so you're going to click on measure up here. Okay, and so I'm back on the top bar of a space claim. So we're going to click measure, and then we're going to click on this button here called measure. And so if you read the tooltip for measure here, you can see that you can basically click objects to measure them. Okay? And so basically what we want to measure is the distance, in this case, the horizontal distance between this this beam and the bottom of the bridge. Okay? All right, so let's go ahead and click measure. And first thing you're going to measure is you're going to measure the beam like this. Okay? And then you're going to hold control, and then you're going to click the bottom surface of this bridge right here, okay? And you can see right now it's measuring the kind of the perpendicular or the minimum distance in between these 2 points. But we don't want this minimum distance here. What we want is kind of the XYZ distance, which is going to be the distance that we're going to move it vertically, you know, to hit together with it. And so on the left right here, you're going to click this check mark for show XYZ vectors. Okay. Right. And so let me go ahead and do just like this. Oops. Right. Let me zoom out a bit. So let me go ahead and click on the Z axis. Okay. And what we want, is since the y direction here is pointing to the left and to the right, what we want is the y distance in between this point here and the bridge. Okay? And this box here is going to tell you just that. And so this box tells you that the y distance here is 0.4127 millimeters away from the bottom of the bridge. Right? And so what we need to do is we need to move this guy at least 0.4127 millimeters towards the bridge. Okay. And then from there, we should be able to extend it. Okay. All right, so let's keep this number in our head. And in fact, I'm going to round it up. And so I'm going to say, let's move it up 0.413 millimeters, okay, just to make sure we make good, contact. Okay. Right. Let me zoom out just so you can kind of see what's going on. Okay. And so we want to take this beam right here and move it in the y direction by 0.413. All right, and so to move an object, what you're going to do is you're going to go to design up here, okay? And so design is right to the right of sketch, right? And so to the left of measure. And you're going to click on this move button right here. Okay? And so this move button will let you grab a certain object in your CAD model and then move them up. Okay? And so let's take this beam, click it, and then we're going to drag it up. We're going to click the beam and we're going to click this arrow right here, this up arrow, since that one's in the y direction, and we're going to pull it. We're going to pull it up. Okay. All right. And so it's going to be really hard for you to get the exact number here, okay, unless you have the dexterity of a god, which I do not. And so what I'm going to do is I'm going to just pull this up by a certain amount just to let Ansys know we want to move in that direction. And you can see here that now we can modify this distance here from this text box. Right? And so instead of 13.66 millimeters, which is way too much, I'm going to change this into 0.413 millimeters. Okay. Right. And so once you've done that, then we've successfully moved this this beam up by 0.413, and we can now extend this.
Can you do that again? I kind of lost track.
Oh yeah. So you're going to click on design. And then you're going to click on move. And then after move, you're going to click on the beam that you want to move. And then once you click on the beam, you're going to click and drag this arrow up and down in order to move in that direction. And then you're going to input manually the distance that you want to travel, which is 0.413 millimeters. Yeah. Yeah. So I've already moved it, so I'm not going to move it again, but this is kind of what it looks like. And so you're going to click the blue arrow, you're going to drag it up and down. And then from here, Yeah, from here you can set the distance. Okay. But I already moved it, so I'm going to move back to 0. Okay. All right, and so now that we've done that, this beam here should be aligned. Okay. And so now we can extend it again. And so go back to the Prepare tab right here. Okay. And then from Prepare, you're going to click Extend. Right. And then once you click Extend, you can see that Ansys has found 2 more locations where you can extend, which are exactly the beam that we just moved up. Okay. So let's go ahead and click OK, and then OK. Right, and then now we can see that that beam, which was previously not connected, is now connected. Okay. All right, and so we're gonna need to repeat this for the last 3 beams here that aren't connected. But before I do that, are there any questions on that step?
How much was the value you said to move it up again? 0.413?
Yeah, 0.413.
Okay. When I do that, it doesn't after that it doesn't extend. So I
did you measure and see how far it was? You might be looking at a different beam. So I was looking at the one that was kind of in between 2 beams that was already extended. But if you're looking at a different one, then then the distance might be different than that.
Got it.
Yeah, and so you need to do the measure. So I'll show you how to do the measuring tool one more time, and then you can apply that method again. Okay, and so let's go over again how we measure that distance in between the 2, because we have 3 more beams that we need to move. Okay. And so let me work on this beam right here. Okay, so the first thing we're going to do is we're going to measure. Right? Click Measure, Measure, right? And we want to get the Y distance in between this beam, or the end of this beam. So let me click on this point right here, okay, and the bottom surface of the bridge, okay. And you can see from the text box, and let me zoom in, just get a better look at it. Okay. You can see that the Y distance that it needs to travel up is 1.8987 millimeters. Okay, and so I'm going to move this up 1.899 millimeters. Okay, just to make sure that it touches. Okay. So here's kind of a better view. Okay? And so if you look at this triangle right here, then the vertical Y distance that needs to travel here is 1.8987. Okay. All right, and so let's remember that number, 1.899. Okay, and let's go ahead and move that beam. All right, and so just like we did before, we're going to click Design. Okay, and then we're going to click Move. Okay. We're going to click on the beam that we just measured, and we're going to move it up by that amount. Okay. Right. And so remember, you don't have to get it exact, just get it close. And then we're going to put it in manually, 1.899. Okay. Okay, and then now this beam should be in line with the bridge. And so let's go back to Prepare. Let's go to Extend. Okay, and you can see now that we can extend these two beams right here. Go ahead and click the check mark, hit the check mark. Okay. And now these guys are extended and hitting the beam just like it's supposed to. Okay, so I'm gonna go ahead and do that for 2 more beams. But if you and so go ahead and try that on your own. And if you have any questions, just let me know.
So when you measure it for the beam, you go to the edge of the beam, right? And then do you go to the bottom line, or you go to the face that you're trying to measure between?
Yeah, so I'm going to the bottom line, because that's all we need to go to. Yeah. Yeah, and make sure you have the show XYZ vectors highlighted here, because you want specifically just the Y distance in between the beam and the bridge. All right, and so I can see this one is minus 1.4797, and so I want to move this up 1.48. Let's go to Design, move this one, move it up to 1.49. Okay, and let's go to Prepare, Extend, yes, yes. Okay. And then last one, so let's go ahead and measure this. Measure this. Okay, you see this one is 1.922, and so let's move this up 1.93. prepare, extend. Yes, yes. Okay. And so now with that, all of the beams are now connected to the bridge. Okay. And now our beams are good to go. All right. So any questions on this? Okay. And so once you have all your beams connected, let's go ahead and bring the road back. And so let's go ahead and click this check mark next to solid 3. Okay. And you can see here the road is back. Okay. But the road also is not connected to the bridge, and so we need to go ahead and move that so that it is. Okay. And so, but instead of moving it up, you can see here that the road needs to be pushed downwards, right? Because ideally the road should be resting right on top of the columns here, because the columns on the bottom are supposed to be giving that road support, right? And so we need to move this road down. But once again, we need to measure how much the road needs to move down. So we're going to click measure here. We're going to click measure, right? And so let's find the distance. Actually, we need to find the distance from the edge of the road down to the bottom edge of the bridge. Okay. And you can see here that the y distance that it needs to travel is 28.37. Okay. And so I'm going to move it down 28.37. Okay. I don't want to move it too much in this case. If I move it too far down, then it's going to move too far past the bottom of the bridge, and then it's not going to connect, right? And so for this case, I want to only move it down 28.37 millimeters. All right, so let's go ahead and click design, move. All right, I click on the road, and we're going to move this down 28.37 millimeters. And so now that now that the road is moved down, let's go ahead and connect it to everything else. So we'll go ahead and click prepare, click extend. Okay. And then now you can see that the sides of the road here are highlighted in red. It's a little bit hard to see, but you can see that they're red. And then you can click on this check mark here to finally extend it. Okay. And so if your roads are red, then you can go ahead and click the check mark. And then you can see from there, then the road has been widened in order to reach all the way across this bridge. Okay. Okay. And so in the end, what you should have is you should have your bridge where everything is transformed into beams and shells, and then everything that should be connected to each other should be connected. Okay. So any questions on this so far?
Sorry, Professor, how did you move the entire road? I accidentally just moved one side.
Oh, so I clicked on kind of the middle of the road, and so when you click design and you click move, I just clicked the center of the road such that you make sure when you're mousing over it, then the entire thing is highlighted. Then you can move up and down like that.
Thank you.
Mm-hmm. Okay. And so now now our geometry is prepared, and so now we can go ahead and jump into the meshing and all that stuff, right? So I'm gonna go ahead and close on space claim. Okay. You don't have to worry; it should save. And then once you're done with that, go ahead and double click the model, and this is going to bring up Ansys Mechanical for us.
So I'm trying to keep up here. How do we know exactly how much to move the road?
Yeah, so you can measure it as well, and so you can measure the side of the road and then the bottom edge of the bridge, and then you can find the y distance in between that as well.
Oh, the same bottom line that we did for the beams, right?
Yep. Mm-hmm.
Okay, cool. Thanks.
Would it matter if the road is slightly above?
Slightly above is okay, and so the main thing is I want them to be able to extend and intersect with each other.
Okay, so but the beams below, I mean, shouldn't the beams themselves be below, or does it matter if they're like on top of it?
Since these are 2D and 1D objects, they're basically going to be right on top of each other.
Okay.
Okay, just waiting for Ansys Mechanical to boot up. And so after a bit of waiting, then you should get this surface here. Okay. As you can see that we have our geometry that we imported, which everything is converted to shells and beams. All right, and so first thing we're going to do is you can see, if you kind of remember from the beginning of this activity, we had this kind of weird toothpick-looking thing up here. I'm actually not sure what that is. It's kind of some remnant of the CAD, but it's going to screw things up for us. And so let's go ahead and just suppress it. Okay, and so you'll be able to identify it pretty easily because it's the only surface here that's with a question mark. And so let's go ahead and right-click this, and then let's go ahead and just suppress it and just not going to worry about it. Okay. All right. And so from there, you can see our geometry here, right? And so normally at this point, what we do is we mesh the geometry, and then we apply boundary conditions, and then we simulate it. Okay? The only problem with that is that here, because we modified the geometry quite a bit, there are no connections that are in between all these different parts, right? And so we have all these beams and we have all these shells, but none of them know that the other ones exist. And so we need to make sure that we put connections with each other to make sure that they're bonded. Okay. All right. And so in order to create a manual connection, you're going to go to the project outline on the left, okay? And then you're going to right-click on connections right here. And then after you right-click connections, you're going to click insert, and you're going to click manual contact region. Okay. And so if you read the tooltip for this function right here, what this does, it allows us to insert a contact region on an object and specify the type of contact, right? And so in this case, what we want to do is we want to bond together, all the beams, to the parts where they need to be bonded to, and all the shells that need to be bonded. Right? So we're basically going to create a bunch of bonded connections in all these guys. Okay, so let's go ahead and click create manual connection region. Okay. And when you create a manual connection region, you can see that we need to specify two objects here. So one of them is going to be the contact, and the other one is going to be the target. All right, and so let's do something simple first. So let's connect the side of the road. Okay, and so let's go ahead and make sure that we're on edge selector here. Okay, because all we want to do is we want to collect, contact the edge side of the road. Okay, and then you're going to go to the very side of the road right here. And you can zoom in to kind of help you out here. Okay. And you're going to click on this edge of the road just like that. Not the bottom edge, the side edge. Right? Right. And you can see that since this side edge kind of runs right alongside the bridge, this side edge should be connected to the actual side of the bridge right here. And so with the edge of the road selected, go ahead and click contact and click apply. Okay. And so you can see on the top left right here, we can see we have the left edge of the road, okay? And we want to bond that together with the side of the bridge. Okay? All right, and so so the side of the bridge, we're going to go to face selector mode, okay? And we're going to select this entire face of the bridge, okay? And we'll go hit apply. Okay, and now the side of the road and the bridge here are bonded together, and so they're going to be basically connected to each other in the simulation. All right. So any questions on forming that bonded connection? Okay. And so let's go ahead and do that for the other side as well. And so let's go ahead and right-click on connections. Go ahead and insert manual contact region. I'm going to do the same thing. So I'm going to click the side of the road. Oh, make sure you're on edge selector. Okay. And so you're going to click this side edge of the road. Make sure you're on this horizontal one right here. Okay. Go ahead and click apply. Okay. You can see here that we're on this red edge of the road right here. And then for the other surface, we're going to click on the side of the bridge, just like that. Okay. And then now we've bonded those two, right? And so now our road is connected to the bridge, okay? And it's not going to go, it's not going to do its own thing. So it's all going to go together. Okay. And so that's that's connecting the road to the bridge. And so now let's connect the road to kind of all the supporting beams on the bottom. And so let's go ahead and right click contacts, insert, manual contact region. Okay. And then now we're going to click connect the surface of the road. Okay. And so make sure you're on face selector mode up here. Okay. And so we're going to go ahead and click the road surface here. Okay. And click on target. Okay. And then for the, for contact. And then for the target, we're going to select all the beams here on the bottom. Okay. And so make sure you're on edge selecting mode here. And then let's go ahead and click all the beams. And so you might need to hold control on your keyboard in order to select all of them. Okay. And so in total, you should have 7 of these. 1, 2, 3, 4, 5, 6, 7. Okay. And then once you've selected all 7, go ahead and click apply on the target. Okay. And then what you should see here is that right now it's not really happy with this because it's you're connecting this surface to each of these 7 edges. And so what Ansys likes to do sometimes, it likes to reverse these. And so what we should have done is we should have made the 7 edges the contact and the road face into the target. Okay? And so we just need to swap these. But thankfully there's a quick way that you can swap them. Okay. And so if you right click on this bonded mid surface, the third one we just did, and then you can click on flip contact and target. Okay. And so if you do that, then it'll swap these two. And so now the 7 edges, which were the beams, those are now the contact, and then the target is now the road. Okay. Right. And if you do that, then there should be a green check mark here, and then that should be okay.
Professor?
Yeah. Mm-hmm.
Can you quickly explain what the difference between contact and target? Yeah.
So the difference between that is I think the contact is the thing that should be because basically the Ansys wants to make a connection between these 2 groups of surfaces that you put here, and so I think it's kind of an internal coding thing where you have kind of one to the other one. And I think this one's a little bit picky with this one because we have 7 different edges here and only 1 face. And so I think when you click the contact, you should have kind of the multiple one here, and then the target, which is only 1, you should have that as the target.
Oh, okay, got it. Thank you.
Yeah. Mm-hmm. Yeah, it's still a little bit fuzzy to me too, honestly, but that's kind of just from my own experience. That's kind of what I've seen, is that when you have multiple, it does a little bit better, or Ansys likes it better when it's on the contact, and then the singular ones, it likes it better when it's on the target. Yeah. What's the target that the selection should make contact with? Yes. Yeah. So basically, that's the target surface that you want to make contact with the other stuff. Okay. And so we have one more connection or 2 more connections that we have to make. Is we have to make sure that the beams here are connected to the bridge. Okay. All right. And so let's go ahead and create a manual contact region. Oops. Or insert. Okay. And this time we're going to connect each of the points here at the end of the beams to the bridge. Okay. And so this one's a little bit tough because it's we're gonna select kind of the individual points here at the ends of the beams. And so just like we did before, it might be good to kind of hide the road for now. And so let's go ahead and right click on the mid surface 3. Let's go ahead and just hide that body for now. Okay. Let's go back to our thing here. Okay. And let's go ahead and select all of the points. Okay. All right. And so make sure our select mode here is vertex, because that's the we want to select the vertices of all the different beams. Okay. And let's go ahead and select all of these points here. Right. And so basically what you're going to do is you're going to go and click the point where the beam contacts the bridge. Okay. And so for the top one, that one's fairly obvious. But for the bottom ones here, it might be a little bit tricky. And so you might have to zoom in a little bit. Okay. Make sure you're holding control on the keyboard so that you're clicking the right regions. Okay. So go ahead and hit apply. Okay. And you should see that you have four different, eight different vertices here. Okay? And so those 8 vertices are for the 8 different beams. Okay? And then our target here, which is what we want them to make contact with, is the side of the bridge. Okay, so let's go ahead and hit apply. Okay, and now we've contacted these 8 vertices together with that with the bridge. Okay, and we're going to do the same thing on the other side, just to make sure that both sides of our bridge are connected to each other. Okay, so let's go and create a new, or insert a new manual contact region. Okay, switch to vertex mode. Right, and then we're going to select all these vertices here. Okay. So hit apply. You can see here we have our 8 different vertices. Okay. And then we're going to select the face just like that. Okay. So go ahead and hit apply. Okay. And then now our 8 beams are connected to our to our bridge. Okay. And so let's go unpack and let's go ahead and show our road right here. Okay. Right. And now we're ready to go for the simulation. All right, and so I know I went through that fairly quickly, but for those of you following along, was everyone able to create all the contact regions for their bridge?
No.
Oh no. Okay. Yeah, it's a lot. So and so you have the PDF, and you're gonna have the recording for this video too. So yeah, definitely use that as a reference. But yeah, it's a lot, and I apologize that I have to go a little bit faster here, but I want to make sure that I show you guys what the mesh and the simulation results look like. Question: so are there 5 contact regions in total? Yes, there should be 5. 1, 2, 3, 4, 5. Correct. Mm-hmm. Okay. All right, and so and so at this point now we've reached a point where we're ready to mesh and start running the simulation. Okay. And so let's go ahead. Let's just look at a mesh and let's see what it looks like. Right. And so let's go ahead and right-click mesh and then click generate mesh, and let's see what it looks like. Right. So I haven't applied any settings yet, but let's just see what comes out from the mesh. Okay, and so you can see here that here is the mesh that we've created. Okay, and so let me do this. Display. Okay, and so if you want to see kind of exactly the types of elements that's being created, you can go ahead and go to display right here, and then there's an option here called thick shells and beam style, right? And so I think it might be enabled by default, but if you turn it off, then you can see, that really, in fact, that Ansys is creating these kind of 1D and 2D elements here, right? And so if you look at the road, the road is basically just a giant rectangle. What all Ansys did was it filled it with quadrilaterals, right? Okay, and so we've really made 2D element types out of these, right? And our beams are just 1D elements, right? And so just for rendering purposes, it added some kind of thickness here, but you can see that it looks like just, one-dimensional stuff, right? And so this is cool. And so, now we've taken this kind of 3D object and we've meshed it with a bunch of 2D and 1D objects. Okay? And if you look at the statistics of this mesh, you can see this mesh is extremely lightweight. And so you can see the number of elements that we have is not even 550. So I've only gotten an element count of 525. And so that's huge. And so that tells us that this mesh is really lightweight, and we can actually refine this mesh quite a bit. So let me actually do that. Okay, so actually let me go ahead and make sure. Let's first make sure that all of our elements here are quadratic. Okay, and so let me go ahead and select all the different beams here. Okay. So let me go ahead and select vertex. Okay. Okay. Oops. Oh. Maybe we can only do it for the for these ones. Oh. Well, that's strange. Usually it allows me to select these for methods. Let me just do one of them. Let's see. Oh. Well, I am running a little bit short on time, and so I'm going to go ahead and kind of delete this for now. But for your homework, for this activity, you should be able to change these such that you get certain. You'll be able to specify like a quadratic order or certain size for the mesh. Actually, let's do it just from here. And so let's go ahead and click this mesh right here, and click element order. Let's go ahead and change this to quadratic just to make sure that we're good on that. Okay. And then for the element size right here, let's refine this a bit because we still have a lot of rooms to operate here. Okay, because we're only at 525 elements, and so let me go ahead and change these units to centimeters, make it a bit easier. Okay, and so let's change the element size here to 5, and so we're going to cut it down by about half. Okay, so let me go ahead and generate the mesh again. Okay. And you can see here that even reducing the element size by half, we're still really good. So actually, let me go ahead and reduce this even more. So let me go ahead down to 2 centimeters. Ah, you just have to body selection or to use method. I see. All right, I'll do that. I'll do that a bit later. Okay. And so with the size of 2 centimeters, then you can see here that we have a really decently refined mesh, but we're only at 6,000 elements, and so we're still good, and so we're still kind of sitting pretty here. Okay. And if you notice, in this shell, with the element size of 2 centimeters, you can see here that we have two elements through the thickness, which is what we want. Okay. Okay. And so you can go ahead and play with the meshing settings, here. And in the activity for homework, actually, what I have you do is I have you compare your simulation results here and the amount of elements that you have with the shell and beam elements compared to if you use solid element types. Right? And so that's one thing for you to try at home on your own. Okay, and so let's go ahead and add boundary conditions to this so we can run a simulation. Okay. And so first thing I'm going to do is I'm going to add a fixed support. Okay. And for this fixed support, I'm going to fix it on one side of the road. Okay. So let me go ahead and fix it on this side. Okay. I'm also going to set a displacement support. Okay. And that's going to be on the other side. Okay. And I'm going to restrict the y component to be 0. Okay. Right. And so that's basically the same thing as we're having a fixed support here and like a roller support here, basically. Okay. And then let me apply just a simple forcing on this in the form of a pressure, just so that we can kind of see the results. Okay. So I'm going to go ahead and apply a pressure on this. Okay. And let me apply a pressure of, let's see, what did I do in the, what do I do here? And so let's apply a pressure of, 5,000 pascals. Okay. And so this is kind of to simulate the effect of like several cars that are sitting on top of this road. Okay, and so now that we have our mesh, we have all our boundary conditions, we're ready to solve. Let me go ahead and put in the things that we want to see. And so we'll just look at standard stuff. And so we'll look at total deformation and equivalent stress. And then we'll solve this guy, and then we'll look at the results.
Professor,
Yep. What's up?
what was the magnitude of the pressure?
So I just did 5,000, and so that's just kind of a dummy value for now, just to get simulation results. But you can put kind of whatever you want for that.
And you put that on the road?
Yes, on top of the road, just like that. Okay, and so let's look at the total deformation, and you can see here that if you look from these simulation results, we get large pockets of deformation kind of on the insides of these beams. Okay, and so that's good, and so that tells us that our beams are properly supporting the road, and we get max deformation in the areas where we're not supporting it. Okay, and so you can see here that we get a max deformation of about 0.28 millimeters. Okay, so very small deformation, and so this road can actually take a lot more abuse than this. Okay, but you can see here that we have a good amount of deformation, and so let's look at the stress. Okay, and so for the stress, you can see we have a maximum stress of 2.42 times 10 to the 8 pascals. Okay, and you can see that the maximum stress here occurs at the edges of the road. And that kind of makes sense because that's kind of where we apply our boundary conditions. Okay. So any final questions on this activity? Okay. All right. So thank you guys for tuning into this activity. And so this one's going to be due in 2 weeks. So just like every other Ansys activity, I give you guys 2 weeks for that. Okay. And so, go ahead and start working on it. And then, if you have any questions, please let me know, and I can help you out as best I can. Okay, so thank you guys for tuning in today. Sorry that I kind of had to go quick over a few steps, but hopefully, once the video is posted and once you referencing with the PDF, that a lot of these instructions are clear. All right, and so keep an eye out for the review poll tonight. I'm gonna go ahead and post that, and then tomorrow I'm gonna record that review session. So thank you guys for tuning in today. Hope everyone has a good weekend, and I'll see you guys next week.
Okay, thank you.
Thanks, guys.
So just real quick, I've fallen kind of behind on working on the project and the assignment that's due tomorrow. Do you mind moving that like a couple days or something? Because it also seems like a lot of other people are also still working on that.
You mean the Ansys activity 4?
Yeah.
Okay.
The
yeah,
Ansys activity 4 that's due tomorrow.
Okay. Yeah, I can push that back until Monday night. How does that sound?
Okay.
Yeah.
Yeah, that works. Thank you.
Okay. Okay. Yeah, I'll push that back, and so that'll be due on Monday, 11:59.
Professor?
Yep.
For this one, I mean, I know we didn't do this probably because of time, but would we have to assign separate materials for the different parts? Because I assume they're all static steel or structural steel right now.
Right. Yeah, that's a good observation. So right now they are all structural steel, but in reality you would assign different materials to each of the different parts. Yeah.
Gotcha. Okay.
Mm-hmm.
Will we be doing that for this activity, or does it matter?
No, for this one, I just wanted you guys to focus on just the shells and beam stuff, which is already kind of a lot. And so you can do it, and you're free to experiment, but it's not a requirement for this one.
Gotcha. Okay.
That's a chunk.
Yeah.
You're gonna have a chance to post the solutions to the homework this weekend.
Yeah. So I'm probably gonna post it probably tomorrow. Yeah.
Awesome. Thank you.
Yeah.
I spaced out for like 2 seconds and I missed all the fixed support and the few steps after that. Would you mind going over that real quick?
Sure. And so for the fixed support, I fixed on one side of the road here. So if you look at the geometry, there's kind of a short end and there's kind of a long end. And so this one, the road doesn't extend past, and so I fixed it here. And then for the long end, I put a displacement support. And so I made the Y component of displacement 0 there. And so just to make sure that it's supported in that direction, but I left the X and Z components free. And so those are the supports that I did. And then for the loading, I applied a pressure on top of the road, just like that. And I applied a load of 5,000 pascals. So I just put in just a dummy number for now. But I think part of the assignment is to kind of estimate something yourself and put that in here. But I just did something just to kind of make sure that we finished on time. So I use 5,000 pascals, but I only have just this pressure and these fixed supports. And then the deformation should look something like this.
All right, thank you. Appreciate it.
Also, just remembered another question I had. Do we have like a date for the progress report that we have to do for the project?
Let's have that due the week after the midterm. And so let's have that due not next week, but the week after that.
Okay.
Yep.
Good to know.
So May, we'll have it be May 6th.
May 6th. Got it.
Mhm.
Okay. I'll see you.
Okay. Yep. See you next week.
Yeah.
Okay, quick question.
Sure. What's up?
Progress report.
Yep.
So what sort of information do you want in it? Just like a paragraph saying this is where we are?
Yeah. So if you can show me just kind of describe where you are, show me some screenshots from Ansys. You know, these are the mesh. Like these are the mesh that I have. This is the simulation results that I have. Just whatever you've done, you know, for the project, just let me know. It's more of a check-in than a progress report.
Okay.
So
this is also going to be my graduate project, right?
Correct. Yes.
Okay.
Yes. Yeah.
Okay.
Yeah. So
and you want something a little more involved than what everybody else is doing.
Yeah, we've already. I think I gave you kind of feedback on that on the proposal, and so as long as you do kind of what we've talked about before, that's good.
Okay, I'm behind on everything right now.
aren't we all?
I got 2 exams coming up next week, and now for 2 homework assignments.
Oh shit, that's a lot. Well, best of luck. Hope everything's okay.
Okay. Talk to you next week.
All right, talk to you next week.
Okay.